Okay, everybody, it's time to wrap up this exploration of deep time. This is Class 12, Evolution 4, Part 5 of 5. And we're now going to look at our time that we live in called the Cenozoic. So let's get started. So here's our geologic time scale. We started at the very beginning all the way during the Hadean period, and then we moved all the way up through the time scale, all the way up through here, and then through the Paleozoic, and then through the Mesozoic we just completed, and this was the KT extinction at 65 million years ago that then triggered the beginning of a new time period called the Cenozoic, and that's where we are now. So during the Cenozoic, several events happened that are worth noting. To begin with, the continents shifted to their modern configuration. Here's a picture of what Earth looked like about 50 million years ago or so. MA stands for millions of years ago. And we see this is very similar to what we see with today's planet in terms of the continental configuration. After that asteroid impact, it took a while, but life recovered. Many organisms survived the asteroid impact, and they went on to thrive in the Cenozoic time period that followed. That includes furry creatures, furry vertebrates known as mammals. That would be our type of organism that we are. And they gradually became the dominant land vertebrates on the planet, meaning animals with backbones. My precious birds also survived, and they're doing just fine, and they were able to survive that. At least some of them, just like some of the mammals, were able to survive the asteroid impact, as did the ancestors of modern insects and plants, and basically anything else that's around the planet today are survivors that survived that impact. It's also worth noting that very late in the Cenozoic, the first hominins arose. Those are the very first humans, modern humans, in early forms that wouldn't look exactly like us, but they would look much more human than, say, our nearest relatives, the apes or so. So this is a pretty dramatic and important time period for shaping the world as it is today. All right, so zooming in on what things were like in the southeast, in Alabama in particular, during the Cenozoic, let's look briefly at two time periods. First, the Tertiary, and then the Quaternary. All right, so this map to the right shows the mid-Tertiary time period, which is the first of the periods in the Cenozoic. This is the approximate site of Montgomery. Here you see the fall line that we talked about before, right? This is the beginning of the Appalachian Mountains. The Appalachian Mountains, you could hop on these mountains from Montgomery and follow them all the way up to New York State and beyond. Far beyond, in fact. Anything below the fall line is all coastal lowlands, coastal plain, developed from ancient seafloor material. Okay? Now, during the early Cenozoic, things were initially quite, but things gradually got cooler as the Cenozoic matured, as it got closer to modern times. And of course, and this was happening because Earth's climate was cooling. And as it cooled, sea levels dropped. Why did they drop? We'll visit that in just a minute. Hopefully by now you already know why sea levels would have dropped as Earth cooled. Also during this time period, the North American continent drifted into its position that we see today, bringing it to higher latitudes, meaning closer to the North Pole, and therefore bringing it into cooler zones on the planet. The Quaternary, down here at the bottom left, that would be the time period that we're in today. It's a phase of alternating cold and warm periods. The cold time periods known as ice ages. We'll talk a lot more about that when we get into our climate change section, and you guys will learn a lot about that as we move forward. Okay, let me throw this question to you. Which of these is not one of the reasons why sea levels might have dropped as the planet cooled in the Tertiary? So go ahead and hit your pause button here and think about what your answer might be, and then I'll reveal what the answer is. Okay, so let's go through these possible choices. Again, the question is, which of these is not a reason why sea levels would have dropped during the Tertiary? Do you think that there was less water in the oceans? That would certainly lower sea levels, but that's not one of the reasons why we see ocean levels change and certainly drop. So that is not a good answer. Is cold land more buoyant than warm land? No. In fact, the opposite is actually true. So that is not an appropriate answer. What about cold water taking up less space than warm water? Actually, that is true, and we will talk more about that when we get into our climate change section, because that's one of the reasons why sea levels are rising so much, because warm water expands compared to cold water. But the most important reason is that as the Earth's climate warmed, we had a lot of ice accumulating at the poles and high mountains, and that wound up having a cooling impact on the climate, one that we're still seeing the residual of today. So D is your best answer. C also gets points, but A and B are off target. Okay, let's take a look now at some of the events that really shaped Alabama and the Southeast during the Cenozoic era. As sea levels dropped, the coastal plain emerged. So as the Gulf of Mexico's edge gradually moved further and further south, you see the little arrow that I'm drawing on the map. As sea levels dropped, it revealed the land that we now call South Alabama and southern Mississippi and so forth. The other thing that happened during the time is that enough water dropped that the Central American land bridge emerged. There was also some volcanic activity along there. It's part of the ring of fire that we talked about in our geology unit, and that leads to a connection between South America and North America. That connection between South and North America basically closed off the Gulf of Mexico as well as the Caribbean from the Pacific Ocean. And as a result of that, we get if you look at the picture at the lower right, we get what's called the loop current. And it's this current that traveled up from the Caribbean Ocean, Caribbean Sea into the Gulf of Mexico, spins does a 360, and then comes out here through the Florida Straits. This current, as we learned about when we studied climate, brings warm tropical water that originates here in the Caribbean and brings it up closer and all the way to our doorstep up here off of the northern Gulf Coast, and that brings heat as well as warm water that evaporates and gets blown inland. That becomes the rains that we get so much of here in Alabama. Okay, so that all answers the question why the loop current was so important. Now, the other thing that I want to talk about here is that the Quaternary currently has two epochs that are designated: the Pleistocene and the Holocene. The Pleistocene is known as the Ice Ages, and so let's take a look at that and what happened during the Ice Ages. So this is a picture of the Earth's surface during the Ice Ages. You'll notice pretty immediately that a lot of the Earth's surface is covered up with this white stuff. That's basically representing ice. So these were glaciers that were up to 2 miles thick that covered much of North America all the way down through the Ohio Valley. So the Ohio River is basically the southern edge of where those glaciers came. So much of North America was iced over during this time period. The southern hemisphere had massive amounts of ice develop on Antarctica and expand outward from there. High elevations in the mountains of the world would have gotten very cold, lots of ice and glaciers, and basically the whole planet got very cold for a long period of time during the Pleistocene. This map represents the last of the ice ages at about 18,000 years ago. What we're going to learn about when we study climate change in more detail is that during the Quaternary, and specifically during the Pleistocene, it would be cold for a while, and then it would get warm again, and then cold for a long while, and then warm briefly, and then cold for a while. And it would go back and forth like that a bunch of times. And the very last of those ice ages peaked around 18,000 years ago, which by now, you're probably thinking, wow, that wasn't really that long ago, since we've been talking about hundreds of millions of years at a time. Yeah, in geologic terms, 18,000 years ago is just is nothing. Okay, if we zoom in and look at the eastern half of North America, we'll see some more detail about what life was like during the Pleistocene. So the white up here, as I'm indicating the boundary with the red line, this indicates the boundary of where the glaciers came down in North America. So Alabama would be right up, I'm sorry, Birmingham would be right up around here. So if we were to drive about 6 hours north, we would hit a wall of glaciers, maybe longer than that, 6, 7, 10 hours north, whatever. Basically, northern Kentucky, southern Indiana, southern Ohio is basically where those glaciers came down. The vegetation in the rest of North America changed because it got so cold and so dry during this time period. And we wouldn't have had forests covering the eastern U.S. at this point. Instead of forests, it would be grasslands with scattered trees. We would have some forests in some of our river valleys and some of our sheltered valleys in our mountains, but otherwise it was a very, very different landscape than today in terms of the climate and the vegetation that we would have had there. Now, one of the reasons that Alabama has so many species relative to many northern states is that it was not covered up with glaciers. All the states that were covered up with glaciers at this time, their entire ecosystems have had to rebuild since 18,000 years ago. Whereas here in the southeast, the ecosystems have changed a lot because the climate has gotten warmer and wetter after the ice ages, but those ecosystems are still intact and species were able to survive here during the ice ages. So that's one of the major reasons why we have so many species in the southeast compared to regions that are farther north. Okay, let's move on. Now, I think the Pleistocene might actually be my favorite time period in Earth's history, because it wasn't that long ago, and because of all the crazy huge mammals that were roaming around the landscape at the time. This is a famous diorama from one of our national museums. I can't remember which one, that sort of illustrates all these animals at once. You would never see this many animals at one place at one time. But all of this to illustrate the different forms of organisms that were around in North America. There were multiple species of elephant-like organisms. There were mammoths like you see depicted here. So mammoths like this guy. We had different species of horses like these guys in the lower right. There were American lions that you see depicted here. They were 50% larger than the African lions, for example. Here you see some bison. We still have bison today, but there were several other species in North America. This bear is now extinct. I think that's the short-faced bear, but that's one of several species of bear. Here's another that were around during the Pleistocene. There were many species of wolves and other canids. Basically, it was a landscape very different from today in terms of the wildlife, one that I would just personally love to go back in time and see. Okay, this slide is just simply some more eye candy about some of the cool things that were going on at the time. Different species of elephants around the world. They weren't called elephants. Well, nobody was there to call them anything, but well, we call them mastodons and we call them mammoths and other species like that. Large predators to eat all these herbivores that were all around North America and Asia and South America and Africa. We would have had lots of herds that would have migrated with the seasons. During the warmer months, they would have moved north, and during the summer months, they would have moved south. So Alabama would have been right in the middle of that migration zone where coming through even the Birmingham area would have been massive herds of animals, and they would pass through the cuts in Red Mountain, the cuts, and wind through the valleys to get down to the coastal plain during the summers, during the winters when it got really cold, and then they come back up north again when things would get warm again. This is just a fossil of a very odd creature called a glyptodont to illustrate that we had some forms of organisms around at the time that are no longer with us, in addition to some of those that I showed you before, including some very strange-looking animals. These glyptodonts are basically the size of one of those little smart cars. they're heavily armored with this external bony shield. You can imagine that that shield would be really helpful if you're dealing with a lot of large carnivores with big teeth that could come at you if you're a slow-moving herbivore wandering around in wetlands and eating wetland vegetation. You'd be very vulnerable without that armor. Now, what happened to all these crazy mammals that were roaming around North America, Australia, Africa, Asia, and so forth? Where did they all go? Why aren't they around today? Well, in some places of the world, a few species have survived, notably Africa. But essentially what happened is that we now know from looking at the archaeological record that as humans moved across the planet and radiating out from Africa, they basically hunted a lot of these species to extinction. And of course, this was happening at the same time that the Earth was warming. So these animals were getting hit with a double whammy. On the one hand, the Earth was warming, and so they had been adapted to these very cold conditions, and were now having to deal with much warmer conditions. But that alone would not have been enough to cause them to go extinct. All these species had survived many warm periods during the Pleistocene. There was nothing new about the warmth that came in this last time period. In terms of the climate, there was nothing new. But what was new is that people had mastered hunting techniques and were spreading out around the planet. So we find, for example, in our soil records, in our archaeological records, we find the bones of the megafauna, lots of bones, and then we start to see bones that have cut marks in them that could only have been derived from tools manufactured by people, and then we find spears and charcoal and evidence of humans. And then in the more recent time periods, we don't see bones of the megafauna anymore. We just see bones of the species that are around today, like deer and antelope and the modern bison and so forth. So basically, nomadic hunters in North America brought a lot of these species populations down to the point where they then went extinct. Now, how does that? It doesn't explain all extinctions for sure, but it explains a lot of them, and even species that weren't hunted. So, for example, if you were saber-toothed cats, or sometimes people call them saber-toothed tigers, and humans wiped out your prey species, and you got nothing left to eat, or not much else to eat, then that can cause your species to go extinct as well. So that wraps up the exploration of the Cenozoic, and actually wraps up our exploration of deep time. That hopefully that gives you a better understanding of like how of the forces that have shaped the modern Alabama landscape today. Why we've got so many different types of rocks at the surface, and the different topographies that we have, and the different species that we have. In our next unit, we're going to tie all of that stuff together to explain why Alabama rocks it out when it comes to having so many species.